Hi, I'm Spurti Hokrana and I'm presenting Sentinel PVM for Track 2 PVM Smart Contract. Sentinel is a stateless Rust cryptographic coprocessor that lets Solidity contracts verify ED25519 signatures by calling into Rust libraries compiled to pull KVM. Now imagine a farm with 10 IoT sensors measuring soil moisture, temperature, pH, irrigation flow. Every few minutes, these sensors generate readings that need to be trusted by buyers, insurers, auditors. But here's the catch. There's no central authority, no one to vouch for the data. So how do you prove it's real? The obvious answer is blockchain, but ED25519, the standard signature scheme these IoT sensors use, has no EVM precompiled. It doesn't exist on Ethereum, it doesn't exist on any EVM chain. Verifying just 10 signatures in pure Solidity would cost 11 million gas. The transaction reverts. It's mathematically impossible on standard EVM. Sentinel solves this in 3 steps. Step 1. An autonomous Python agent acts as farm's IoT backbone. It collects sensor readings, soil moisture, temperature, pH, irrigation flow, all that, and then it generates a fresh ED25519 key pair and signs each readings individually. This is the same cryptographic standard used by real-world deep-in hardware. In step 2, all 10 signed readings get packed into a single binary payload and submitted to our Solidity gateway on-chain. Here's the thing. The Solidity contract doesn't try to verify the math itself. It makes a standard call to Rust contract compiled to pull KVM. The Rust contract uses the ED25519 dialect crate, an industry-standard cryptography library, and verifies every signature natively at RISC-V speed. The chain bridges EVM to RISC-V automatically. No precompiles, no special Solidity libraries, just PVM engine call payload. In step 3, if every signature checks out, the batch hash is permanently anchored in the EVM state. Anyone, a buyer, an insurer, again an auditor, can query is verified on-chain and mathematically prove the farm data was never tampered with. No middleman required. Now, let me show you this live on the Passio testnet. So, a Python agent here, it simulates the farm sensor readings across 4 zones. Yeah, done. So it signs each readings with a fresh ED25519 key pair, packs them into a binary payload, and submits to the deployed Sentinel contract. So the agent connects to the Passio asset hub. There's a wallet of balance in Pass tokens. Step 1 is again generating the 10 telemetry data. Here you can see the sensors, types, value, zone. In step 2, it signs telemetry batch again with ED25519. Here is our agent's public key. In step 3 is the binary payload is built. 1284 bytes, that's a 4-byte header plus 10 128-byte entries, each containing the public key, message hash, and signature. Now in step 4, this is a comparison. Look at the table. Pure Solidity EVM has no ED25519 precompiled, 11 million gas estimated, and it's extremely expensive. Whereas in PVM, there's native ED25519 dialect crate, single transaction, all of that. And in step 5, submitting to Sentinel on Passio, gas estimates comes back as 96,000. That's it. The transaction is sent and confirmed. In step 6, we query the contract directly. Is verified true. The batch hash is permanently on chain, and look at the summary here. 10 elementary entries. Again, 96,000 gas used via PVM. Compare that to 11 million on EVM. That's a 99.1% cost reduction from a single standard solidity call. Yeah, so that's it. That's it. Now let me switch to front end and show you there. The front end tells the same story visually. Let me connect the wallet. Okay, so we have checked all of this. And why farmers choose Sentinel? It sells for more, lower insurance, total transparency, all of that. And okay, the farm data. Here, if we hit run verification, you see the agent's terminal output streaming live, each sensor tile lighting up green as it's verified, and the final transaction hash linking directly to the Passio block explorer. This is the same real on-chain flow, just visualized. Now let me show you the technical page where we break down exactly why this architecture works. On the left, traditional EVM verification, it's $4.82 per batch, takes 24 to 48 hours, requires manual paperwork, records can be lost and forged. On the right, Sentinel verification, it's $0.004 per batch, verified in under 6 seconds, completely automatic, permanent and tamper-proof. Same farm data, completely different economics. But the real question is, why PVM? The answer is simple. EVM was never designed for heavy cryptography. It's 256-bit stack machine. Operations like ED25519 verification require curve 25519 field arithmetic, like modular exponentiation, point multiplication, none of which have pre-compiles. You'd have to implement all of that in Solidity inline assembly, and the gas cost is catastrophic. PVM, on the other hand, is a 64-bit RISC-V register machine. It runs native Rust code. So we just import ED25519 DALEC, the same crate used in production by Signal, Tor, and most of the Rust ecosystem. And it just works at the bare metal speed. So if we run the comparison, so traditional EVM reverts at 11 million gas. The gas bar fills past the block limit, transaction fails, whereas here in Sentinel PVM succeeds at 95,000 gas, same 10 farm sensor signatures. One fails, one works. Yeah, that's it. So again, both of these contracts are deployed and live right now on the Passio testnet. You can see the Rust PVM verification engine and Solidity Sentinel protocol side by side. Okay, with their on-chain addresses and direct subscan links. Click on any of these and you'll see our actual deployment transactions. Everything is verifiable. Yeah, so Sentinel PVM started with a simple question. What can you actually do with the ability to call Rust from Solidity? And the answer turned out to be something that EVM fundamentally cannot do alone. Verify cryptography that has no precompile at a cost that makes sense in a single transaction. Yeah, the code is open source, the contracts are live, and every number I showed you is on chain. Thanks for watching.